Sumit, you need to admit everyone. Admit. I'll do it. Sumit, you can remove the screen. Let's go live. Professor, we are live. We can start.
All right, a very good evening to all of you, and thank you for joining in and for taking the time to be with us this evening. Here is Dr. Gurizada and I, who are going to spend the next maybe half an hour, 35 minutes, taking you through a little bit of work that we have done around marketing analytics. Specifically, what we have chosen to kind of talk about today is this topic, extracting meaning from images and text, implications for marketers. So essentially, probably the first 10 or 15 minutes, it is I who will be kind of taking us through an overview of some of the changing realities for the marketer and why marketers need to be interested and interested in this particular topic, and why it is important for marketers. And then I will hand it over to Dr. Gurizada, who will be taking us through a little bit of a hands-on demonstration of what it all means. And so here goes. So essentially, we know that the realities, the data realities for the marketer has changed. And how has it changed? Much of it is there on the screen. And what we note is that a question that often gets asked is about, is marketing analytics the same as marketing research? Is marketing research obsolete? What is this thing that is different from marketing research? Because marketing research is something that we as marketers have undertaken for a very, very long period of time. And so that's a place where we're very comfortable in. So what we've tried to do is to probably bring out the differences and kind of underscore the need to embrace the changes that are taking place, which may push us a little bit out of our comfort zone, but not doing that may actually hurt us badly as in the role of marketers. So if you think of marketing research, much of it has been around, of course, collection of data and analysis of data. And essentially, we've gone to our respondents, seeking responses from them. So we have usually framed our questions. Many a times they are open-ended questions, many a times they are close-ended questions. We have done all of those things, face-to-face and different other formats. However, with the data environment that we find ourselves in today, where a lot of data are getting generated because of user activity on the internet, users are leaving a lot of footprints on the World Wide Web in the form of activities that they undertake or actual posts or comments that they make. Sometimes it's unbeknown to them, sometimes it is done consciously. Whatever the reason may be for the user to undertake that activity, much of that is getting captured because technology enables us to do that, and that creates a lot of data that marketers could look into and maybe find patterns or set them up in some sort of a model and analyze user behavior and derive insights from there. So essentially, the world of marketing analytics, as I see it, is really driven by technology, and you're essentially bringing technology-led analysis. And that's probably one of the ways of explaining analytics. And so there's massive amounts of data that are making themselves available. And therefore, instead of more of a hypothesis testing approach, which is what traditionally marketing research does, maybe we also need to supplement that with a data mining approach. And some of these, Dr. Gurizada will actually take us through some of these specifically. Also, what we, in terms of difference, what we note is that when we think of marketing research, many times we are interested in finding that one or two features that are important in understanding the user's behavior. With marketing analytics, it is really about, okay, I'm trying to predict something. What is the accuracy of the prediction? Because we have a lot of data that will allow us to now do that. And also the parlance changes slightly when we are in the realm of marketing analytics, and we tend to refer to data as being structured, semi-structured, or unstructured. And so let's look at some of these examples of semi-structured, structured, and unstructured data. And what you will find on your screen, so if we can move to the next slide, essentially are some examples of these types of data. So they are just some examples that we have put in there. They are by no means completely exhaustive. So data that we may get from social media, for example, people use emojis, people use text to express themselves. Sometimes they put up audio files, sometimes they put up video files. There are images. So you can see there are all sorts of formats that people are using to put data up. And if we were to use a marketing research approach, we have done that. We were doing that all the time. For example, our focus groups and then the content analysis that we have used, or a semiotics approach, that is what we have done. We have looked at all formats of data. However, with a marketing analytics approach, much of that is done with the help of technology, with the help of algorithms that allow us to make sense of this data, because in the realm of marketing research, maybe our respondents were in the order of 30 or 40. However, in the world of marketing analytics, we are talking about maybe millions of words, or essentially it could be millions of customers who are actually writing in. And these data sources could be from a variety of places, and it could be transaction data, it could be machine-to-machine data, and it could also be data that are coming from offline. So overall, really, there are three types of approaches to maybe making sense of this data-driven world. And very broadly, we can kind of, refer to them as supervised learning, unsupervised learning, and reinforcement learning. And very briefly, before I hand it over to Dr. Gurizada, what are each of these? Essentially, supervised learning is where the algorithm essentially has an output against which the data is being trained to identify that output. Unsupervised learning is where the algorithm is looking for patterns. It's recognizing certain patterns and coming up with different clusters. So while supervised learning allows us to do classification and maybe some predictions, unsupervised learning algorithm allow us to identify patterns, while reinforcement learning is more of where the algorithm is learning by itself to undertake certain tasks and are then getting reinforcement from that environment via a reward or some kind of a penalty. So say a supervised learning example could be where we have say an image of a cat or a dog, and that algorithm learns to identify that particular image. Unsupervised learning is wherein we have, say, massive amounts of data, and we are interested in identifying certain patterns from there. And then we don't have any specific output against which we are mapping it. While reinforcement learning is where an environment learns, in that environment, the algorithm learns and then corrects its course. Say, for example, a self-driving car or a game of chess, wherein that algorithm tries to learn what will lead it to some sort of success. So with this, I hand it over to Dr. Gurizada to take us through some typical applications of some of these methods in the realm of marketing analytics. Dr. Gurizada, over to you.
Thank you, Dr. Mary. So, like she just mentioned, when you take a data mining approach to the kind of marketing data we have, suddenly our world expands because we now have not only the vocabulary but also the machinery to handle a lot of data, and possibly data which we have been sitting on for a long while, and the methods have either not being sort of used or have themselves not matured for widespread applicability. And over the next 15-20 minutes, the endeavor is going to pick up a few of these scenarios within images and text, and pick up situations where marketers could possibly use data at hand to achieve certain objectives. And in terms of the kind of approaches that you will see that we will be referring to the supervised and unsupervised learning approaches as we go along. So to pick up a first example in the domain of say images. So think of you being the brand as a brand, a sponsor of one of the IPLs, and you're very interested in the kind of ROI you get out of the matches. So there is a broad viewership data that you get, like a match that's being telecasted probably got about 500,000 views. What does it mean for a brand exactly? It doesn't mean that 500,000 people actually saw the brand on television. What they actually see, the viewers, is this, right? So, and if you look at it, where is the signal is in terms of what is really, really crucial for a brand is right there at the top left corner of the screen. And that is an impression that a brand should really count. It doesn't, and in this, in fact, is a very valuable impression. It could come at a point of, over a period of time, the number of viewers are sort of like that. Impressions that land here, that is when the logo of, say, Vivo appears at a point when there is very little interest in the match, and that's not a good impression at all. So just having broad-based viewership, that's good in sense that you get a sense of whether you're spend on the sponsorship was worth it or not, but then you could do finer grained measurement. Once you knew how to analyze images like these, then you could precisely say how many times was the logo shown, at what time was it shown, and if you map it to the number of viewers who were alive during that match, or three-hour match, you could precisely say whether the brand impressions were delivered at a particularly memorable time, and whether the investment that was made was really very was good or not. So there's a lot of meaning that one could derive, but the problem here is that how do you count such kind of impressions? This is something which is new to the world of marketing, because this is not data which can be analyzed readily or directly with the methods that we have on hand. And so let me just take you through very quickly the intuition behind how such data, which is essentially an image, and the intent here is to count how many occurrences of a certain brand might happen. So I'm going to do two things. If you carefully watch the screen, I've done two things now. I've just laid a grid. There is a square box which I'm calling a detector. This is what I'll refer to later as a model. But essentially, I've just laid a grid of across the image of the same size as the detector. And the intent or the intuition behind me counting the impression of whenever Vivo is there on the screen is going to work something like this. We want this detector to sort of move across the screen. We want it to stop or in some way notice when Vivo is there. We also want it to discriminate in the sense it should move all across the screen the way it is, but it should not return anything or any signal because there's nowhere else the Vivo brand is there. So it should move across all the grids of the same size as this detector, but it should only give me a signal when there is actually a logo, right? So this is essentially what I've just described. Is what is known as is at the heart of what are known as convolutional neural networks, which are essentially doing this. Given an input image, which is this image which you say on the screen, I lay a grid of size, a similar size to the detector that you just saw, technically referred to as a filter. And the filter just moves across the screen, and wherever there is a logo, that's when it registers that as the as a hit or as a presence. Now, why is this? Why does this work, right? So first, we note that the logo could be there anywhere, right? It could be there on the player's cap, it could be there on their shirt, it could be there on their sleeve. We want our method not to change every time the logo changes somewhere. The second important thing is that the logo itself doesn't change. Vivo, whether it's there on the top, on the ground, or on the player's shirt, looks exactly the same way. So while the detector remains the same, it makes sense for it to slide across the image and then register a hit whenever the logo is actually seen. So this is a typical supervised learning setup where you have an image. So input data is the image plus an annotation or a signal given that the logo is there at a certain position. And the model is just what we saw. It's just overlaying each of these images on a grid and then running this detector across the grid. And this as it sees more and more images, it learns to detect the specific pattern that is unique to Vivo as a logo. Now, so how much of a data do you need, right? This what I've described seems to be horribly complex. It seems to need a moving box across all of these images. But if you take, say, a 3-hour match, which is about 180 minutes, and you take a snapshot of every 1 minute of that image, and you get 180 images, and usually that's all you need, given the current state of art and computer vision. That's all you need really to sort of develop this detector. And if you learn, if you train your model on the first match, it's good for prediction all across because the environment doesn't change. The players play on the same field, kind of a field. The logos are at possibly the the position of the logos on are not very different, and hence this method scales. And this is why computer vision has sort of exploded in the past few years, and this is at the core of how supervised learning is used to learn or make sense of images. In this case, we are trying to make sense of where the logo might be. It might be anywhere, but given this whole approach, it scales to any image which has the logo anywhere. Now, if you put a little bit of more concrete explanation around what I just said, It works something like this. If the intuition possibly has sunk in, that it's just about sort of dragging a piece of square across the entirety of the image. But then what exactly is happening is something like this. If you really zoom into, or if you worked in Photoshop, you will know that every image, if I zoom into it, is essentially a set of pixels. And if you could see those pixels as square blocks around here, the way that this data, image data, gets stored is that each small square is stored with a number between 0 and 255. 0 being dark because there's no brightness in the sense, so it will show up as a black color on your screen. 255 being white, so that shows up as the bright pixel. So if you see this whole IPLI, it's essentially is stored on the computer as blocks of numbers, all of them being 255. And if I split this entire image into individual pixels, it essentially is sort of a matrix. If you recollect high school math, it's essentially whatever be the dimension of the image, each of them being a number. And if I map this to this matrix, it essentially is this 255 is running around as the I, which will corresponding to this particular position on the image. So what you see to the eye as an image is stored as numbers in a matrix. And this whole dragging business, which we just saw, you take a square and then you're dragging it through, is essentially taking that filter, which is the one that you see here, the detector, referred to as filter, and you're just dragging this, is essentially multiplying that with the matrix that you have just seen. So this whole business of dragging is essentially taking that small square and moving it across the screen. As you move across, you see that the things are getting multiplied. And if there is a logo, if there is a signal, suppose here is the signal, then that will have a very high value. Or if the signal is somewhere here, then that value will turn out to be high. And this detector, by moving across the screen, learns where the signal is maximum, because we have annotated that to be here. So as this filter moves across, it will find one position where the activations or the values of the matrix are maximum, and that's how it figures out that there is a logo there. And once learned, it can just do the same thing when it wants to make a prediction. It just runs across the entire image and predicts places where such kind of numbers were found. So that's sort of how machine learning looks at images. Very, very different from the way we look at it, but it also provides us a very highly scalable system to understand what is there in an image. Things get a little bit trickier if you could see that Ebix logo is there across sort of two rows of these squares. But the method itself doesn't change. I still slide a square, and that activates when at least some portion of the image is there. And put together, I know the precise location. So the method, you could see scales even when, unlike Vivo, it's there across, but the method doesn't change in effect. So this is a great method, and given an input, this is how a typical computer vision output looks like. It tells you what logos are there at what position in the image. And if we go back to the initial discussion, now I know exactly at what point or what time which logo was shown. And if I could map it to engagement figures, I could know really when of these logos were shown at specific points in the match. If you scale it up, it doesn't matter. Once you've trained a Vivo classifier, you could train a Tata Safari logo identifier, you could train an Unacademy identifier, and you could use those on the same image, and they'll tell you where exactly who is. And so at crucial points in the match, say suppose at a very exciting last few balls, how many impressions of Vivo were delivered, how many impressions of Unacademy were delivered, how many impressions of Safari were delivered is much more fine-grained, precise data, rather than telling me that 500,000 people were watching this particular moment which you're seeing on the screen. So this is one. So what I've just taken you through is, in fact, commercial grade. A lot of people are actually using these as a part of the toolkits, which are being applied. Another very, very widely prevalent way in which image analytics is used is to count SKUs on a retail shelf. Conceptually, not at all different from what we've just seen. All you do is to train a small patch, a filter, to run across a picture of a aisle in a supermarket. And whenever it matches the, say, a Mountain Dew bottle, which is a matrix multiplied by another small matrix, and whenever the activations trigger, all that happens is it tells me that it's a Mountain Dew bottle. This, in fact, is a very, very, very common application which we have seen scale over the last 2 years, where now literally every big FMCG major is transitioned from manual counting or manual inspection of planograms within retail stores. Everybody relies now on image analytics, where the salesperson goes to the store, takes a picture, and an automated algorithm simply counts up and matches the display to a predefined planogram, and then either gives the retailer the discount as agreed or penalizes them for not displaying products appropriately. So recognizing objects and placing them exactly within the image has become like a very dominant way in which images are being analyzed, and hopefully I've given you a flavor or the intuition around how these things work. This is not just, this is one way or a supervised way of having an input image and training something to recognize where an object is precisely in the image. When we don't have any such themes as well, by understanding what exactly is there within an image, sometimes makes a lot of, gives us a lot of intuition or insight into the contents of a large collection of image, or if you want to take a global view of a set of images, understanding or having a classifier which is understanding the different portions of an image is often very helpful. And here, what you're seeing on the screen is a clustering of a very large number of images. Now, I'm not making a prediction on one image, but rather I'm collecting thousands of images, and I am sort of projecting them onto a two-dimensional space, like you see. And what is happening is that the images are sort of being placed and rotated so we could see. Let me pause the visualization and zoom in into, if you zoom into the individual images, you could, there is no label here. These are just images that's being clustered by the kind of features that the neural net observed in it. And if you pause the visualization here, you could observe a green patch here. And if you zoom into that,
Dr. Gurzada,
you will see that all of these are images with.
I think, we are not being able to see the screen. Could you kindly check?
Okay. Okay, I think I lost my screen share. Yeah, I think screen share is lost. Okay, so let me. Is it okay now? Am I back on the screen share?
Yeah, that's good.
Right.
Yeah.
So what you're seeing on the screen is a projection of a lot of images. All of them have been run through a prediction setup, the convolutional setup, just like what we saw. But then I don't have a label. In fact, I'm trying to understand putting all these images or what is known as embeddings onto a low dimensional space to understand, are there any natural groups that occur within the image? And if I zoom in or go close into the space that you see, you will see sort of a patch of greens, a lot of images with green background and something in the front. And imagine that you're sitting on qualitative data, say pictures you've taken from the customers' homes, pictures, and these are real projects that we have sort of done. So if you have images of people's kitchens, if you have images of what people use to cook, all of these could be used to sort of put together. These can give you a very rich understanding of what things sort of go together in the mind space of a consumer. So in this way, this is an example again of an unsupervised sort of an approach where you have no specific target in mind. The aim here is to try to understand if there is any pattern within all the images that you could collect. And qualitative research is sort of being really changing with this aspect of it, with this turbocharged by our understanding of by the ability to process a large sets of images. They are still processed exactly the same way which we just saw, which is dragging a square across all of these images. So these are the two themes which we observe are happening within the realm of analyzing images. One is that of detection. This has really become very mainstream, which means that a lot of commercial grade applications are really doing this at scale, which means millions of images being detected, used for detection on retail shelves or otherwise. What is getting traction more and more, especially in the last year and a half, is that things like what we just saw, We are trying to extract themes out of groups or selections of images. If I move on to doing a similar thing on text, big thing on text is, especially in the last 2 years where algorithms have really matured, it wasn't until 2018 that we could analyze text the way we do today. And after that, really rapid advances have taken place, largely driven by Google and Facebook's contributions to understanding natural language and conversational AI. And the good thing is that it has a very important side effect, which means now we can also understand a lot of consumer speak, which is being generated not only on social media. And here I take specific examples of product reviews. If you have a corpus of product reviews on Amazon or wherever your product is hosted, you could employ things that similar to what you've just seen to understand what do people associate with your brand in terms of words, in terms of consumer speak. For example, here is a review I've taken of a headphone from JBL from Headphone Zone. And and if you read the review as a human, this is how probably you will read it by word. These headphones look very premium, but the overall loudness is less, and the consumer goes on to complain about some features which they didn't like. This is typical of a review. There'll be some things that people will like, some possibly a few things that they don't like. Just like we saw what the intuition behind how images get analyzed, if I give you the intuition of how text gets analyzed, it works something like this. The model masks or blocks out one word. In this case, I have blocked out one word in the entire review. And I train a model to predict whatever is missing here, given the rest of the sentence. So if I gave you this sentence and I asked you, what would this missing word be? What would you predict? And it does some prediction. And when we show the word, it learns that, okay, this word should have been headphones. And I slide the window again, a few words, and now I tell it, I ask the network, if I give you everything else, can you predict this word? And once that is done, I essentially slide the window across.
Professor, Dr. Guruzada, I think, you've probably gone to the slides. I think we're not able to see the slides. We are still seeing the images. Yeah.
Okay, let me reshare the screen. You can see the screen now.
Yeah, now we can see.
Right. So to recap, so the way a machine learning algorithm would process this is by masking one of the words. So in this case, I have just masked one of the words and asked the model to predict what this word would be given the rest of the sentence. So it's going to read the entire sentence, try to come up with a guess. The first instance is going to be pretty horrible, but when I show what the word was, it's going to learn to predict that, okay, this word should have been headphone. And by sliding this, just exactly the way I slide a square through an image, and masking different portions of the sentence, I force a model to learn what are the kind of words that are there in the sentence, and most importantly, what kind of words are there before, after, and the relationship that this masked word or the hidden word has to the rest of the sentence. And as we keep on doing this over a period of time with a lot of sentences, what the model is actually learning is the relationship between the words used by consumers about this brand, JBL. So in effect, we are training this whole machine to learn the relationship between the words. What words do they tend to get used together? What words not tend to get used less often, and things like that. The side effect of this thing, and the way the training is done, is that even sentiment analysis has improved dramatically. Previously, the input that the output that we used to get out of typical sentiment analysis is whether the sentence or the review was a positive or a negative. As you can see here, since I'm dragging a certain masked word across the sentence, it is able to detect at which points did the sentiment really change. So it started off well, they look very premium, but the overall is less. And then there is another dramatic change to even more negativity when as you go along. So you can see that it's literally like the model is reading every word, and as it reads the word, it is pausing, looking back what it has seen so far, and making up an opinion about how negative or positive the whole word is. And this is tremendously nice, because not just do we know that overall it was a negative review, we also know what exact features were most negative, or where was these sentiment changes precisely done. So I know that the equalizer of the phones is not great, because it doesn't allow us to listen to specific genres of music properly. This is more powerful than telling me that the review is negative, which is possibly already known. If the rating is say 2 or 1, that I already know. But by training a model to learn patterns between words, I get these very crucial points, which are the changeover points, the crucial points within the review where emotional changes have happened. And that can really point me to specific product features which are possibly getting flagged through this whole process. So in this case, it's again a supervised sort of a learning approach. The input is the text of the review, and the label, or these or the outcome or the target for which we train is possibly the rating. If this review had this text and was given a 3-star rating, and if I could sort of use this as a way to flag this as a positive or negative. For instance, every review which got a less than 3 rating is negative, and if it got a more than 3 rating is positive. I have in effect an entire training set which is comprising this text as the input and the label, which is the positive negative label. What is learnt really is of very importance to the marketer is these points where the emotion sort of changes, and our ability to detect changes midway within the sentence is something fundamental which has happened over the past couple of years. Now, not only do we, like I said, we not only understand where within the sentence is the emotion changing. Since we are learning which kind of words occur together, we also learn representations of words. And what you see on the screen is the text from 132 reviews, which we took out, a small sample of reviews for Parachute Advanced coconut oil on Amazon, a very specific SKU of all these reviews. We put them through a similar sort of a setup, which we just saw. But now we are trying to look at what are the words that people use around, say, a key parameter like quality. If I want to know as a Parachute, the brand, what do consumers speak about my brand when it comes to, say, quality? And if you look at the map, I mean, you could there's a lot of meaning within what is there very closely associated with quality in the context of these reviews. And if you can pick up those specific words and dig into the embedding, like it's called, it can give you a very rich insight into what do people associate with the brand in terms of perception. What do people think about this brand? And that is all coming to us from a product review text, which was being posted on Amazon. So this again is again an unsupervised approach. There's no label here for us to train. The intent is to understand the relative ordering or the relative relationships between words. You will notice that this is different from the way we have seen images, because here the order of the words is important. In an image, the logo of the Vivo, wherever it was in the image, is the same, but the same word used at one place might mean very different if it was really used another place. So in that way, text is more difficult than images to process, because every single position of the word can make a lot of difference in terms of the meaning that word gets. So that in essence has also been the reason why processing text has sort of not really taken off till the past couple of years or so. So essentially, you could even query the same review. You could query, given a word which I'm interested in, what are the words that are closest to this word in the mind or in the usage of the consumer's word. So this is great insight. I get to know what words do people use when I'm trying to pitch some of my features. So all of this is become possible because of our ability to process and to make sense of large amounts of text. In terms of the two big themes in practice that are coming up, emotion detection is now pretty much standard. It comes along with several standard packages as well, and is used very widely. Like I said, the most important change possibly that has happened is that we can detect now things just like humans would, change of emotion at specific points during the text. And theme extraction, like I said, is possibly another major way in which text is getting analyzed. So in terms of summary, this is what we wanted to share beyond the broad guidelines which Dr. Mehdi shared. In terms of images, industry-grade systems are now there to identify and detect specific aspects of the image. And that is sort of increasing the, or is contributing a lot into effort measurement. What was vague in terms of overall broad views is getting more and more precise, because now we can detect and identify objects more clearly. And the world of qualitative research is changing because of the methods we have to visualize and cluster images. In terms of text, sentiment analysis and emotion analysis has become really, really powerful, because now we can specifically highlight portions of the corpus which are contributing to this emotion. And also visualization of the vocabulary of the consumers. And given that now we can process literally many different languages, vernacular, and a lot of messy stuff which was difficult to handle before, all of this is giving us rich insights into brand associations. So this is sort of a broad overview of what we had. I guess I'll just stop my share, and then we'll look at any questions that might have come in along.
Dr. Mehdi and Professor Gurzada, there are some questions which have come in the chat box. So how marketing analytics or data analytics will help to learn new concepts, that is neuromarketing, to grow a brand? That's one of the questions.
Yes.
Professor Mehdi, you are on mute, I think. Yeah.
Yeah, I'm so sorry. Could you please repeat the question?
Yes. It says how marketing, so this is from Mr. Vijendra Rastogi. He's saying how marketing analytics or data analytics will help to learn new concepts, that is neuromarketing, to grow a brand.
So neuromarketing essentially is when you're using fMRI techniques in order to map the specific parts of the brain to specific responses to images. Now, essentially, if you are able to generate a large number of images from brain scans and those kind of things, then you could essentially probably use both supervised and unsupervised techniques in order to find meanings from those images. So supervised could be used, say, when say you have one person whose brain scan images you have mapped to the kind of expression on that particular person's face. And these are some of the traditional ways in which fMRI techniques have been used in understanding people's responses to advertising. And now that's wherein you can say, okay, this is the kind of response that we are getting when people see this kind of an ad. Now, if you have similar responses that you get from many people, then you could start using those fMRI images to find patterns. And then say, okay, these are some of the typical responses that we see in a large number of people when they watch the same ad. So that's one way of approaching or learning about what people think when they see a stimulus, and it can now be extended to stimulus as well. But at the same time, let's understand neuromarketing does require specialized data, because we need data that are from brain scans and all of that. So because of that, the application of neuromarketing has been fairly limited until and unless you're one of the really large organizations that have some of these labs that where they do these kind of testing. I hope that addresses your question.
There's another question. How can one use images for customer segmentation? Any example?
Yeah, Dr. Gurzada, you may go ahead. I mean, I think.
Right. So, so I mean, there's a bunch of things that come to my mind. So, speaking from my own experience, so we could see, so without sharing the name of the customer, we collected images of the ingredients that people use during cooking and the benefits or we could do a benefits sort of a segmentation where depending on the kinds of ingredients that people use, and all of this is coming from pictures of images, like you could see that haldi and things like that, they go together, and that's one sort of a segment who use a certain set of products in a certain way. And you could also, if you can tag possibly the kind of images who's posting this image, that could also be a way in which you could say that this kind of consumers usually express themselves in this way. And it could be consumption scenarios, like say a consumer who's sipping a cup of coffee might be doing it in different ways, totally different ways, depending on the kind of person they are. They could be doing it in an outdoor place with friends in a coffee shop, or they could be sharing pictures of themselves having an evening cup of tea just with alone. As in, that's a very two different kinds of segments. And just looking at these images, and if you saw the plot, it will split them out because it's fundamentally two different consumption experiences. So there's several ways in which you could use this as an initial base. And again, to underscore, this is an unsupervised approach, right? So this is where you get all these ideas, and then once you do that, then you go back and rigorously quantify whether this is a sizable sort of a segment and whether really this is something worth pursuing.
There's one last question. I think we just have time for one last question. And so it just says that, is the image placed on the basis of trials conducted with viewers, and based on the results, it's placed during the telecast of the match? And so I think this is the PPT, I think so.
Yeah, correct. So the cool thing here is that so you get from the telecaster very broad guidelines on how many people were actually watching the match. As an advertiser, you get that data out, but you don't get fine-grained detail in terms of at what exact places was your brand shown. That is something that is, unless you make somebody sit, watch through the match and count all places where Vivo is shown, right? So the cool thing here is that you don't need to do that manually. The timing or the placements of those logos are in fact not under the control of anyone, right? It could just happen that the ball went there and then your impression was landed. If you look at broad view metrics, then it's going to miss such kind of moments. So it's not about whether a brand was able to place it correctly or not, but it's about having this set of images can give great insight into which specific points where the brand impressions were shown. And like I said, it could be associated with great moments, in which case there are a lot of positive association which the brand would have got. It would miss this point if it just looked at broad viewership numbers.
I think there is one question there which says, is theme extraction similar to thematic perception test? So do we have time for that, Ms. Rai?
Yes, please go ahead.
All right. So see, thematic perception test is a projective technique, and essentially we use projective techniques for a whole host of things. As you already know, since you're asking that question, in order to elicit thoughts that may not be readily accessible to people in a that kind of sense. However, theme extraction is very much based on the stimulus that is right in front of us. So if it is text, then the theme is already there in the text. The algorithm is allowing us to sift through that large amount of data and get to the kernel. So the kind of social network analysis graph that Dr. Gurzada showed us toward the end, wherein this he has analyzed some reviews from Parachute Advanced, and we essentially look at the quality, and then we see what are the main themes that are associated with quality. And these are actually in the words of the reviewers themselves. So in that sense, theme extraction is very much stimulus driven. So it's based on what we have in front of us. A TAT in terms of a method is a projective technique. And so each of them has its own place. We want to connect the two. then I could say, do a TAT, see what responses you get, and then from, whatever response you get, you could run probably, theme detection algorithm and kind of, get the themes from it if you want to bring the two. But TAT is a method in which we kind of, talk to people, and it's a projective technique essentially, while theme extraction is trying to.
And in fact, you would recall that we actually did this on actual transcripts of qualitative research, where it's the same concept. Instead of having a product review, you run it on the transcript from qualitative research, and that is again projective in the sense that somebody is really prodding and pushing somebody to get those themes out. The trouble is that it's up to the skill of the researcher to also interpret the data. What we are saying is that if it's there in a written form, there are methods now powerful enough to get those themes out, and they do prod them in terms of, so that this is the prototype, can you speak about the quality or your user experience? And that's a very clear key. And then you could run the similar methods and get out these themes. So the researcher sort of focuses on their key skill, which is eliciting that theme out from the consumer, and the method focuses on sort of working on larger amounts of data rather than say 30-40 participants per city. We could scale to say 100 or 200 participants per city, because you're no longer worried about actually processing that much amount of text. Sorry, I just extended that thing. But
which softwares are used for this image and text mining? Sir, please tell us the software that you use for image and text mining.
Okay, so if you want to get your hands dirty yourself, so in terms of images, I think TensorFlow and PyTorch, both of them, they are great tools to pick up. If you can code a bit, then there are a lot of ready-made models as well. In terms of text, what has really become very powerful over the past few years, couple of years, is this package, a Python package called Hugging Face, Transformers package, and all of the text-related results that I've sort of very quickly shown are all from there. So we could possibly include links to these packages once we share the as a post-event sort of a takeaway.
Thank you very much, Dr. Mehti and Professor Gurzada. Thanks a lot for your time. Very interesting session. We really enjoyed it. And we've got quite a sizable audience here today. So thank you so much. Thanks a lot for your time.